Do you feel the vibes?
So back in the day, we learned, when we were learning how to factor, we learned how to factor some patterns. One was difference of squares, right? So for example, if you have a squared minus b squared, that factors as a minus b, a plus b. And then we learned about perfect square trinomials, right? So for example, if you have, x squared plus 10x plus 25, remember that's like x plus 5 squared, okay? So now, today we're going to do sum and difference of cubes. Sit up. Yeah. Okay. You can move somewhere else if you want, but like sit up. Okay. Today we're going to do sum and difference of cubes. Now, in the case of the square, in order for us to be able to factor, we need this to be squared, and we must have a minus in the middle. So for example, if I have a squared plus b squared, I can't factor that. But in the case of the cubes, I can. I have both possibilities. So sum and difference of cubes looks like this. If you have sum of cubes, a plus b cubed, here's what you do. First, you take the cube root and the cube root. Easy enough. Then you square the first one, multiply the two, then square the last one. It's a very easy pattern. So let's look at the difference of two cubes. You have a cubed minus b cubed, cube root, and then square, multiply the two, square. Now let's talk about negatives. In both of these cases, you only have, it's like you have like math bucks, right? Like money, like math currency, math bucks. You only have one negative to spend, okay? So if you have a positive here, this must be a positive here, so you have to put the negative there. But if this is a negative, then this must be a negative, and then you've spent your negatives and the rest will be positives. Okay? So let's take a look at this first one. So here I have 27x cubed minus 8y cubed. The first thing you want to do is see if you can factor out a GCF. In this case, we can't. So you realize this is a perfect cube, right? 27 is 3 cubed. X cubed and 8 is 2 cubed, and x cubed is cubed and y cubed. Okay, so now we have this and then we have this. So look at what you do. Cube root of the first one, 3x. Cube root of the second one, cube root of 8 is 2y. Because there is a minus here, the minus goes there. Now you're done with negatives. You've spent your negative token. Now, the rest is, look, square, multiply, square. Okay, so square the first term, I get 9x squared. Square the last term, plus 4y squared. And then just multiply these two, 6xy positive. Okay? It's got to be positive because you spent your negatives already. So that's that. Okay, let me do another one and then I'll take more questions. Okay? So let's take a look at the next one. The next one I have 64 and 25. They're
25 is not perfect.
64 is
Yeah, 64 is perfect.
okay, so right, but remember these are cubes. This is cube. So even though f cubed and g cubed are cubes, 25 is not a cube. So we cannot factor this in this way. So we would just say prime. Yeah, it's back. Okay. I know it's come back. So this one, 24 and 3, we can factor out a 3. And what else can we factor out? X squared. So I get 8x cubed plus y cubed. Okay, so the 3x squared has to come along for the ride. Now here I do have perfect cubes. So the first case, it'll be the cube root of 8x cubed, which is 2x, and y. Does plus or minus have to go in here? Plus. Now here, look up here. Square, multiply, square. That's what we got to do. So 4x squared. Then multiply the two of them. 2xy, but that has to be negative. And then y squared. So look. Remember how we're getting this term and this term. We're getting those by squaring. So they've got to be positive. So it's got to be plus 4x squared plus y squared. Right? Okay. Next one. Can we factor out a GCF? 5y. So I get y cubed minus how much? 64? Z cubed. 64, is that a perfect cube? Yeah. 4, right. So here I get 5y. Okay, what do I get in this parenthesis? Y minus 4z. Here, square the first one, y squared, plus or minus? Plus, how much? 4yz plus, okay, right? So the pattern is square, multiply, square. Okay? Do I need to remove that chair from there?
No, I'm literally just stretching my back.
Okay. Okay. So take a look at this one. So look at this one. Okay. This one is actually, look, x squared cubed minus y squared cubed. Right? So this is a perfect cube. So here I get x squared minus y squared. And here it's going to be x to the 4 plus what? X squared y squared plus y to the 4th. And generally speaking, that second term is not going to be factorable. But can we factor this further? How? X minus y, x plus y. Right? This one? Okay. So, if you think you might forget about this one, what is a good thing to do right now?
Circle it.
Put a star next to it, circle it, right? So then when you're reviewing, you come back to this one. Yeah, now look, there's actually a different way, a second way of factoring this exact same problem. Let's take a look at that one. X to the 6, y to the 6, and we do get strangely like different looking solutions. So take a look. What if you were like, wait, but these are also both perfect squares, right? So look, this would be x cubed plus y cubed, x cubed minus y cubed. Okay?
Oh, that's really fast.
So now, look, this is sum of cubes. So I can do x plus y, just like I've been doing in this lesson, x squared plus x minus xy plus y squared. And then this one, x minus y, x squared plus xy plus y squared. Right? So two different ways. And they both take, like they both come down to factor by cubic, difference of cubes. Okay, yeah. They're not, they're both okay. If you multiply these out, they'll both turn out to be the same. Okay? Okay, so they're both okay. So now take a look at this one. This basically just sums up all of the different ways that we've had to factor. And usually we go by the number of terms we have, right? So factoring out a GCF, that goes for any number of terms. If you have a binomial, 2 terms, it's, you know, you're going to use one of these, right? A squared minus b squared, a cubed plus b cubed, this one. If you have 3 terms, then we can factor it by a perfect squared trinomial. Or, you know, just, you know, guess and check like, you know, the other way, right? If you have like x squared plus 5x plus 6. And then if you have 4 or more, one way is by grouping. So why is this useful? How to use this chart? Now you've given like something to factor. And you're like, oh my God, what do I do? What do I do? What do I do? Well, okay, let me just count the terms. Okay, this has 2 terms, right? So let me see if I can use different steps here. Like, are they both perfect squares with a minus? Are they both perfect cubes? I could do it that way. And then you're like, oh wait, no, this one has 3 terms. Okay, let me see if, you know, there is a pattern. And then 4 or more, you can use this. So take a look at this one. These we can definitely factor by grouping. The way I like to do this is split it down the middle. So from the left side, what can I factor out? And I get a plus 3y. From here, what can I factor out? Plus 2y squared. So what do I have? A plus how much? 3y. If you do it correctly, okay, you are going to have, or if it's possible to factor by grouping and you did it correctly, you're going to have a common term. So we're going to write that common term off to the side. And then whatever we haven't used, a plus 2y squared, that goes here. And boom, we factored. Yeah.
It just looks so nice now.
Right. Yeah. Okay. All right. So now let's take a look at this one. Okay, again, split it down the middle right here. What can I factor out of here? 6x. So I get, tell me what I get.
5a minus 4b plus c.
Okay, what are we going to factor out from here?
Y squared.
How about negative y squared? What do we get?
5a.
Oh my God, they're the same. Do you see that? They're the same. Look, I have the same things. So write that off to the side. 6x minus y squared here. Then you either, no, okay, hang on. Don't be so quick. It can either not be factored by grouping, or if it can be factored by grouping, then you made a mistake. So it could be either or. But it's not definitely that you made a mistake. Okay? Huh? Or like this one says factor by grouping. So like,
It probably say on the test if
huh?
you want us to factor by grouping.
Right. I won't give you, right. Okay. So now it says factor and solve. When you hear the word solve, you want to find an x value. So do you notice how these are both perfect cubes? 216 is 6 cubed. So here I get x plus what? X plus 6. And then here I'm going to get x squared. Yeah. Okay, so look at the instructions. It says to factor and solve, but we'll come to that. Okay. Okay. Raise your hands if you guys have questions. So here's what we do. Okay. We're okay with this step? So here, x equals negative 6. Okay, can we factor this?
Wait, how come it's in the middle?
No. Yeah.
How come in the middle it's negative 6x? I thought you multiplied by 2.
Do you? Not for these. That was that. That was the binomial. That was the squares on the board. Go back to your notes. Go back to the last page. Okay. So here, we're going to do this using the quadratic formula. Positive 6 plus or minus the square root of b squared minus 4 times a times c all over 2. So x is negative 6 plus or minus the square root of, this is negative 108. 2. Okay? So now we got to take care of this 108. So the 108, right, it's 2 times 54, which is 2 and 27, 3 and 9, 3 and 3. So let's see, x is 6 plus or minus. Okay, 2 comes out, 3 comes out, so 6i root 3 over 2. So now all these can be divided, right? So x is 1 plus or minus, 3 plus or minus 3i root 3. Okay, so now look at the answers. I have this and I have this. If we had not factored, if you had just moved x to the 216 to the other side, all you would have gotten is the negative 6 and not the other two, right? So 2 things here. A, the directions explicitly say to factor first. And B, factoring really does give you like the whole picture, okay? Otherwise, you kind of lose half of the problem. Okay, now, what if you have higher order terms? What if you have higher degree polynomials? So we've done the quadratics, we've done the cubics. What if you have like, something to the power of, 6 and so on? These can be written in quadratic form. Okay, let's think about this for a minute. If you have a polynomial like this, x squared plus 5x plus 6, you can factor it out like that. Okay? The reason why you can factor it out, so let's look at what the pattern here is. You have a constant, then you have a variable to some exponent, then you have the variable, the exponent times 2. So here you have x to the 1, here you have x to the 1 times 2. Now, take a look at this problem A. You have a constant, you have x cubed, and then you have x to the power of 3 times 2, right? So you have an exponent, and then you have twice the exponent. That's what is allowing us to factor in this form. So all it says here is to write the following in quadratic form if possible. So quadratic form will be this. 2x cubed. Okay, so 2x cubed squared minus x cubed plus 9. So basically you have something and then x cubed and then x cubed squared. Okay, so look at this one. This is 8x cubed squared plus 6 times x cubed plus 7. Right? That's in quadratic form. Yeah.
Oh.
For the last one, you just leave it like that?
Yeah.
Like
Wait.
That's it. That's all we're leaving it.
Oh,
How
that.
about negative?
It's an equal sign.
Why is this called quadratic form?
It does, but so no, it's like a quadratic equation,
Oh.
like a quadratic polynomial. Yeah.
Could we technically do the x squared times
No.
cubed instead
No.
on the outside?
No, because you want something squared, so it looks quadratic.
Oh,
The exponent has to be, yeah, it has to be squared.
X2.
that's
Okay, so take a look at this one. Solve each equation. So now this is in quadratic form, right? You have something and then something times 2, the exponent times 2. So we're going to factor it like this. Now, instead of x and x, now we're going to put x squared and x squared. And then here, this is going to be minus 25 minus 4. So this is x minus 5, x plus 5, x minus 4, x plus 4. So finally, x is plus or minus 5, x is plus or minus 4. Oh, 2, sorry, 2. Okay, so this is quadratic form. Okay, this one, we have 4 terms. So 4 or more terms, it's factor, we have to try by grouping. So let's see, from here I can factor out an x to the 4, and I get what? What do I factor out from here? Just a negative, x squared minus 9 equal to 0. Okay, so the common term is x squared minus 9. Write that off to the side. And then I have x to the 4 minus what? 1. Factor further. I know you can all solve it from here, but please factor because you're told to factor. Here I have x squared plus 1, x squared minus 1. Am I done? No. X minus 3, x plus 3, x squared plus 1, x minus 1, x plus 1 is equal to 0. We keep factoring over and over and over again. Look at how many layers of factoring this has. So from here, x is plus or minus 3. From here, x is plus or minus 1. And then here, x squared plus 1 is equal to 0. X squared equals negative 1. Take a square root. What's x equal to? Just I?
x equals just I.
So when you square both sides, what do you get?
Just I. Just I.
Plus or minus I. Plus or minus I. That's what we were missing. Okay? Because we squared both sides, so it'll be x is plus or minus I. So now, let's think about this for a minute. How many total solutions did we get? 6 solutions, and 6 was the highest degree. Hang on. Let's see what this looks like here. Let's see what this looks like here. So I have 0 at negative 1, negative 3, 1, 3. I have zeros everywhere. What's the end behavior for this? What's the leading term? It's x to the 6. It's even and it's positive. So do both ends go up or down? Up. Both ends are going to go up, right? So gotta cross, gotta cross, gotta cross. That's what that looks like. So look, you have 4 real zeros, 2 imaginary ones. That's why you don't see those as intercepts, but 6 total zeros.
That's what you mean by it doesn't have to be.
That's what I mean, but it doesn't have to be the same number, right? 6 total zeros. 4 are real zeros, so it crosses the x-axis 4 times, but then the other 2 have to be accounted for, and they're imaginary, right? And the imaginary numbers, because it always comes from plus or minus, then they have to come in pairs. So in this, either 2 could be imaginary or 4 could be imaginary. You can't have 3 imaginary and the other real. Okay? Isn't that cool? That is really cool.
So going
That is super, super cool. Okay, so now,
Press start.